Welcome to our next webinar with the topic Shutter Control with KNX. Yeah, my name is Thorsten Reibel. I will show you some slides together with Jürgen Schilder, who is sitting opposite to me. And yeah, before we come to the agenda of our today's webinar, let me talk about some organizational topics. As always, at the end of the webinar, you will see, or you will be guided to a questionnaire, to a small examination with 4 questions regarding our webinar. So please complete this webinar by answering to these questions. If you are not able to do this today, we send you a reminder 1 week later latest, and so please do it then at that time latest. As always, we will send you a feedback email with the presentation itself, with a recorded file of this webinar, and also a small ETS project you will see later on in our demonstration with the Ibas tool. In the feedback email, as mentioned, you get the files, or the link to the files, better said, not only for ABB staff, but also for external persons. We have now a SharePoint with all these files, so it's now easy also for our customers, or you can send it also to your customers, this link with this webinar and the presentation itself. Yeah, if you have any questions, here also as always, please write it down in the chat. On the lower right side, you find here the chat where you can send your questions to us, to the host, and to the presenter, and we try to answer this question during the webinar. If not possible, you will get the answer in the feedback email, as always. Good. 1 hour was planned in the morning. We had already this session, and it was a bit longer, so around 115, 120 minutes. I hope it's okay for you, but takes a bit more time. So if you would like to complete, please stay until this time. Good. Yeah, I think so far we can start. Allow me first of all to switch off the video screen as always to improve the performance of the transmission. But you see all my slides, of course, and can listen to me. So, topic shutter control with KNX. What we are going to do right now, first of all, we will introduce you into the topic shutter control, the kind of the applications which are available will be shown to you a bit. And then, of course, we talk about our shutter actuators. There's a complete family of devices, so we go into some parameters, some important parameters you should know, which are also a bit different from maybe other shutter actuators on the market. And then Jürgen will follow with the explanation of automatic control solutions available in the shutter actuators. The basic sun protection solution we have inside, the sun protection with tracking of the sun position, means we position the blinds, the shutters, and also, if available, the lamellas, depending on the sun position. Very powerful solution. Heating, cooling automatic is a further automatic function inside the shutter actuators. And then we have a very special solution, redirection of daylight with blinds which have a reflective surface. So you get a small impression about the solution as well. Sun protection with tracking of sun position and redirection of daylight we will explain in one of the next webinars a bit more detailed. It's not possible today as it's a very powerful solution, and but wait, we will show you in one of the next webinars more about this. Furthermore, we would like to show you a bit about the SMI technology. Some of you might heard of this already. It's a digital technology, a bit similar to DALI for lighting. SMI is for shutter and blind control, but you get also here an impression what's behind. And finally, Jürgen will show you live the functionality of the shutter actuator together with our ABB Ibas tool. You might know as well, which is not only a tool for the shutter actuators, but for some more KNX devices from ABB. Good, let's start. So first slide shows you all the components, KNX devices, which deals with shutter control or blind control and electrical windows. You will see in the next slides applications. There's a big number of devices already available. First of all, the actuators you find on the left. These components we will discuss a bit later in more details. We have also shutter solutions, shutter outputs in some other devices. You see here the Room Master 2.1 and 3.1. There's shutter output or shutter outputs integrated with more or less the same functionality we have already in our standard devices. Our room controller available with shutter modules, both for 230 volt motors but also for 24 volt DC motors. Either similar functionality, not very different. We have also a special flush mounted blind actuator for decentralized installation and not that powerful like all the other KNX shutter actuators, but also possible for this application. And then we have some accessories in the middle here. You need for a consistent solution sometimes, for example, a weather sensor. We will talk about this. Brightness depending control, weather depending control is sometimes a topic. You see here also a separate brightness sensor we have in our range. The presence detector can be also part of a complete solution. You will see later on in the heating cooling automatic as part of the complete solution. And of course for local operation of shutter blinds, whatever, you need also a local push button. So we will concentrate on these 4 devices here, or it's more than 4 devices, but on this family of classical, let me say, shutter actuators. Some impressions with images about the applications. You see here typical shutter applications in residential buildings, outdoor shutters made of plastic or aluminium, completely covering the window, and of course going up and down is a topic here, stopping the motor, but also some automatic function depending on brightness, for example. Very typical solution you find in many regions in Germany here, but also some other European countries in residential buildings. Here, further residential applications, but not only. You see also electrical windows, could be in any commercial project as well, and or roof windows here, an awning for a terrace, and a bit special here, a cover for a swimming pool, also running via a motor, and can be also operated via our shutter actuators. And some more impressions here, blinds with lamellas, so not only up and down is the topic here, but also changing the angle of the lamellas to have more or less brightness coming from outside in the building. Of course, this you can operate as well, not only completely up and down, but also positioning here of these lamellas is possible, which can be also done inside the building with any curtains, with vertical lamellas. You find also sometimes in projects. And in the Middle East region, for example, we have in private buildings standard curtains also operated via KNX. So all these things are possible. So not only up and down and stop here is a topic, but also positioning of the lamellas. Practically, you do it the following way: that you run the motor by for example, long operation on the push button, and then you can run stepwise the motor by short operation, or vice versa is also possible. So double function on a push button. Let's go into some more detailed applications in residential buildings. You can do with the shutter actuators and the dedicated hardware behind. Of course, if you have any shutters or curtains, it's for privacy in your building and also for sun protection. Typical application. Or here a bit more special solution if you control a window with an electrical motor, a roof window, for example, in your bathroom. After showering, you can open automatically, let me say, the window to reduce humidification in the room, and after time, 30 minutes maybe, it closes automatically. Or if you have roof windows as well, of course, in case of rain, it has to be closed automatically. So we need any rain sensor, which is also part of the complete solution. Or you open windows in case of fire alarm, yeah, to get rid of the smoke and to be able to escape from the building, yeah, easily via the window. Could be also a kind of function. Of course, if you have shutters in your private house, it's also a mechanical protection against intrusion. So it increases the safety of the building, and in winter, in cold winters, it also isolates even better the windows. So also for energy saving, quite interesting. If you have an alarm system in your private house, you could automatically move down the shutters at the terrace. If you set the alarm system, if you leave your house, so you have also here additional mechanical protection against intrusion. Also interesting. Time functions could be assigned to a shutter solution. For example, in a private house, you open automatically in the morning all the shutters, maybe except your sleeping room because you're still in the bed, and yeah, could be a further function. If you have a winter garden in your house or your customer, you could open electrical windows as well for natural ventilation, for cooling down the temperature in the winter garden in summer. So this could be done also via a time function or via a temperature. You will come later on to a night cool down application. So here we compare indoor and outdoor temperature, and this, depending on the situation, we open windows to cool down the building. Yeah? And if you have a shading system for winter garden, of course you should close it in case of sun to avoid any overheating in your winter garden. And fresh air, electrical windows can be also used for electrical windows can be used also in the winter garden to increase the fresh air in the room and the building, maybe controlled via air quality sensor. Yeah? Could be also possible. Yeah, let's go to more commercial applications in commercial buildings. Very often also shading systems are existing. In general, for an efficient and comfortable building, yeah, of course, that's a standard in many countries in commercial buildings. Here we can do the following. For example, the sun position depending control of blinds. We will come to this later a bit more detailed. And to improve the situation regarding energy efficiency, regarding lighting, artificial lighting in the building, and also regarding heating, cooling demands. You can keep the sun outside to have less cooling necessary and so on. Redirection of the sunlight into the building to have less artificial light necessary. As I already mentioned, a very special solution. And this heating cooling automatic will be explained by Jürgen later on in more details, just for energy harvesting or for prevention of solar energy in the building, depending on the season, on the heating or cooling situation. Yeah. Night cool down, also something for commercial buildings. If you have electrical windows to cool down the building during the night in the summer, and as well here the option to get more fresh air via electrical windows into the building depending on the local situation. And we will see later on we can also control ventilation or ventilation flaps, I just missed the word, or dampers together with shutter actuators. It has nothing to do with electrical windows but with any ventilation pipes, for example. We will see later on as well. So just a selection of some possible applications in residential and commercial buildings. Let's come now to our shutter actuators. The standard shutter actuators for panel boards, D-rail mounted components. We have 4 different, let me say, families. First of all, the most powerful one, version 5, JRAS, and then in the middle of the type description 5. These are the most powerful ones with travel detection and manual control, available with 2, 4, and 8 channels for AC motors, 230 volt. But the same principle also available for a DC output, 24 volt, for any DC motors. DC motors very often used, or low voltage DC motors with curtains, electrical curtains inside, or electrical windows. Due to security reasons, you don't want to work with 230 volt in this case. So we have one shutter actuator here with 4 channels, but with the same functionality of these most powerful shutter actuators. Then again 2, 4 and 8 volt with travel detection, with no travel detection but with manual operation, and then the final one here without manual operation and without travel detection. And the SMI technology will be explained by Jürgen later on as a separate technical solution. We have there 2 4-volt devices, but later on you will see what is behind SMI technology. So here are the components, 2 4-volt and 8 volt and 4-volt 24 volt with travel detection and manual operation available here. So with a 5 in the middle, followed by components with 2 here in the middle of the type description. No travel detection, but still manual operation, but no 24 volt DC shutter actuator. This is only available with the most powerful solution. And if you don't need any manual operation, you can get it without. Of course, it saves also a bit money. Neither any travel time detection, but all the other functions we will talk about later are also available in these components without manual operation. So there is only not so much difference, but you cannot do any manual operation here, as you can see. The components itself, already mentioned 5, 2 and 1 in the middle, JRS, abbreviation for our shutter actuator. The first number means the number of channels or outputs, and the voltage is the next value or the next number, and then the version number or hardware number. 5 stands for automatic travel detection and manual operation, 2 for manual operation only, and 1 for standard. And then we have a hardware version additionally, which is not so important here at the moment. Let's come to the connection diagram. What's behind a shutter actuator? If you look here at the component, this solution here, it's a changeover contact. So a changeover contact is necessary to run the motor up and down, because we need 2 contacts here for the coil which is going up and for the coil which is going down in the motor, open or close if you have a window. And here you see we have 3 positions in the middle, means motor stops. If you go to the left, we close the electrical circuit from a motor going up, and vice versa on the right side, we close the circuit for going down. So this in this case 8 times, and here you see also the manual operation. Very simple. You can press this button here for manual operation. LED will be switched on to show you're on the manual mode, and then you go to the 2 buttons next to your output. With long operation you start the motor, with short operation you stop the motor in both directions. And the LEDs here indicate running motor with a blinking LED. If you have reached the end position, LED will be completely on. If there's any security function active, we come to this later, both LEDs will be on here for 1 channel, showing you that a normal operation is not possible. If you press again this button here, you go back to the standard bus mode and no manual operation is available anymore. So back to the hardware here, we have a changeover contact. Very often the question, can we connect then more than 1 motor to 1 output? We can connect, but you should not do. You see here it's red cross to this part of this picture here. If you connect 2 motors in parallel, you get problems. Not both hangings or drives run at the same time, so there are end position switches in such motors, and if 1 motor stopped already, the other is still running, then you have a reverse voltage on the other motor, and this occurs leads to problems with the end position switch and the motor itself, and you will destroy very quickly motors and the end switches as well. So don't connect directly any motors in parallel. You can do this via additional isolation relays, possible, but it's additional work, of course, installation, additional money. It's always a question, is it not better to use additional channels in the shutter actuators? You can group later on 2 or 3 or more motors together, no problem. But please don't do something like this here. This will cause problems, and of course you should not do this. If you are interested in some more explanations in this regard, you can go to our application manual, shutter control, and there you find some more explanations around parallel connection of shutter motors. But our so-called two-fold shutter actuator we have is not a real two-fold, it's a 2x2-fold device. You see here the component with two channels, A and B, but each output has two independent changeover contacts. So this allows you to connect two motors in parallel to one channel, but not more. So it's already integrated here, these separation or isolation relays for both channels. All the others have only one output or one changeover contact per output, and it's not possible like this here. But we have one device. Yeah, there's a further option in the shutter actuators, adjustable via the application. Instead of using an output as a motor output, a shutter output, or blind output, you can use it as a switch, in a switch mode. So you change over to switch mode, allows you to operate normal electrical components like a lamp, for example, is also possible. And but you see here examples on the left for any ventilation flaps or dampers, also operated via a normal relay contact only. Just to open and close here completely the ventilation flap, and this is also possible. Remember my application, fresh air into commercial buildings, for example. There you could use something like this sometimes. You can mix in a project also between switch actuator mode, you see here. Maybe the last two outputs here in this 8-fold will be used for classical shutter outputs with changeover contact. So you are flexible to create a solution depending on your requirements. So let's come to the DC shutter actuator. You see a bit different connection diagram here. Low voltage DC motors between 12 and 48 volts can be connected here. First of all, you have to connect your external DC power to the shutter actuator, plus minus. Necessary. And then you connect your DC motors with only two connections here. And to change the direction of the rotation, we change only the polarity internally in the component, and then we change the direction of the motor here. It's a bit different hardware here, and all the functions, we come to this right now, are the same here, including travel detection, including manual operation. As you can see, only the relay hardware, let's say, inside is different. So for any curtains or any low voltage motors, we have also a solution here in KNX. As already mentioned, we have these changeover contacts per channel. You see it here again with all the three positions of the changeover contact: stop, up and down. And as you see, it's not possible that the motor can get at the same time a command to go up and to go down due to the mechanical situation here. Changeover contact cannot go to both positions here at the same time. So we prefer this solution, not two independent relays you could use also for running motors. One relay for up and one relay for down, but independent relays means due to any malfunction of the device, both contacts can be closed. And of course you cannot run the motor up and down at the same time, so the motor will burn and will be destroyed. So due to the hardware situation, not possible in our case, so we prefer the solution, and you cannot have problems I've just mentioned. You can program one changeover contact to a normal switch output as mentioned before, so you have still flexibility here, that's the situation we have in our shutter actuators. A small accessory I would like to show you here for our KNX devices, not only for the shutter actuators, but sometimes used. It's a small commissioning power supply. Very simple device with a plug to put it into the socket, and an output, low voltage output, which can be connected directly to a KNX device, just for using manual operation at the device, without any KNX bus connected. So power is enough to allow you to run the manual operation here directly, and if your motor is already connected with 330 volt, it will work. So please don't use it as a KNX power supply. It has only 30 milliampere output current, and there is no choke inside, which is necessary to have a communication on the bus at all. So just for manual operation at the device itself. Again, it can be used also for any other KNX devices from ABB which have this manual operation available. So let's come to a bit to the software of the devices, the application. You see here functions might be known to some of you as well. The copy and exchange function we have in the ETS available for many of our devices. So this is also valid for other KNX devices in the ABB range, not for all. Copy and exchange means in a device you can copy parameters and group addresses you have assigned already to other channels in the same device, just to save time makes life a bit easier. And so if you have a multi-channel component, you can use this. How to find? If you go in the ETS on the device with the right mouse button, you find here in the ETS4 the plug-in function, and then two other functions might appear, and one of these is copy and exchange. If it does not appear, then it's not available for your device, but many, especially the newer devices, have this function available. So copy and exchange of channels. And furthermore, there is a function convert of devices available with the same principle: right mouse button on the component, plug in, and then convert. This allows you to update the application of an existing KNX device in your project to a newer version maybe. So maybe there's a new application available, you would like to update your device, but you don't want to design or to program everything again, or don't want to parameterize everything again, including group addresses. You only copy or convert from the old application to the new application with all existing parameters and all existing group addresses. The only thing you have to do then finally is to download the new application into the device, but not more. So it makes life also easier, and a function you find also at some other devices. Yeah, now let's really come to the components, shutter actuators JRAS, and I would like to show you some interesting parameters we have in our shutter actuators. Not all I can show, and I would like to show it takes too much time, but let's go through some of these parameters. And one important thing is reaction on bus voltage failure. What shall happen with your drive, with your hanging in case of bus voltage failure? You have some options here. No reaction, so nothing happens. You go up or go down. Or if the motor is running exactly at that time where the bus voltage fails, it will be stopped immediately. So also defined situation in case of bus voltage failure can be adjusted here. You see always in my next slides here a small screenshot of the parameter window inside these shutter actuators. So what more do we have? We have a lot of status messages. Feedbacks from the shutter actuator to the bus may be shown on a visualization software. So position of the blind or shutters, and also the position of the lamellas, if available, can be sent back as a 1 byte value. Or if you're interested only in the end position information, is a blind completely up or down, then we have also a 1 bit communication object available. Furthermore, if there's any safety situation, weather alarm for example, strong wind, this can be shown also. Maybe not only on a visualization software, but also on an LED of your local push button in the room, showing you, manual operation at the moment not possible due to any superior safety situation. Different automatic modes, Jürgen will come to this later, can be also, let me say, visualized as a feedback. It's active right now, for example, in automatic sun protection or heating cooling automatic. And finally, in a 2 byte communication object, we have a lot of information about the channel or the drive itself. For example, wind alarm, motor is running right now, or there's any drive fault, means the shutter actuators with current detection, they work via with travel detection, they work via current detection, and this allows us also to monitor the motor. I come to this in the next slides. Yeah, travel time, just mentioned, available with version 5 of the shutter actuators. At least the automatic or the automatic travel time detection. But what for do we need travel time? Yeah, why is it necessary? In a typical solution, we don't want to run the motor only to the end positions, completely up or completely down. We would like to position our blinds. Our standard motors we use here, they have no feedback. They give us no feedback of their position. But we have to know the position to go to a further position. How to do? We do it via, or indirectly via travel time. So if we know the total travel time from the upper to the lower position and vice versa, then indirectly we can position our blinds. For example, if we know it's 20 seconds from the upper to the lower position and we run from the upper position 10 seconds, for example, then we know that we are in the position of 50%. So current measurement is easily possible, for example, or measuring of the travel time as well manually, and this helps us to position quite precisely our hanging behind. So how is it possible to get the travel time? Now we come to the automatic travel time detection. If we have the version 5 shutter actuator, it's now possible to detect automatically the travel time. And technically we do this via current detection, means if the motor is running, current is flowing, and an internal timer will be started inside the shutter actuator, and if the motor stops, current is 0 and we stop the timer as well. So if we go to we run between the both end positions, we know the total travel time. And can be then detected automatically, not only at the beginning, at the commissioning of the device, but also during normal operation. All the time the travel time can be detected. So in case of any changes of the travel time due to low temperature in the winter, motor is running a bit differently, or the hanging has more mechanical, let me say, problems, it takes a bit more time to run, then automatically this new travel time will be detected and will be stored inside the device. And already mentioned, also some failure messages can be, let me say, detected this way. So if the motor is started with a telegram but no current is flowing, something is wrong, of course, with the motor. This can be also sent as a feedback. So if you do not have the version with automatic travel time detection, what do we do then? So then we have to measure by ourselves the travel time. You see here the parameters in this device, in this case version 2, so with manual operation but no travel time detection. And as you can see, we can we can type in individual times for each direction. If you go up and if you go down, that might be different, and you assign this travel time here directly in the parameters. Finally, you have the same result for positioning. We know the travel time. The only disadvantage is that this travel time will be fixed more or less. So if there are any changes in the travel time, you have to measure again and program again. With the shutter actuator and travel time detection, it's a bit easier because it detects it automatically. What else is available as a nice feature? You see here a so-called time-delayed switching of drives. What does it mean? Assume you have to run all the blinds at the same time due to any security situation, wind alarm, for example. So this will be one telegram to a lot of channels, to a lot of motors, which run at the same time more or less. What does it mean for the power supply, for the power peak? There will be a power peak maybe because all the motors run at the same time, which is maybe not allowed for your installation or causes problems in the installation. So for such a situation, we can program time delays in operation or in running. So means if I assign 1 second to such a drive here, for this case, for this central function, the motor will run a bit delayed, 1 second later after the command. And you can do it with 15 steps here. So practically you will create groups of drives and run this group of drives a bit delayed, and on the other facade maybe another 2 seconds later, and so on, resulting in a delayed or not an existing power peak in your installation. For local operation, of course, still immediate reaction if you press your button in the room, so you don't worry, you will not have any delay in this case. But only you see here for some central travel telegrams like wind alarm, like forced operation. We come to this a bit later. Quite nice function. You can also limit the travel range. Yeah. So, for example, also for some central commands for central ventilation of your building with electrical windows, you don't want to open the windows completely. So then it works via this communication object limited traveling. And if you go to your local push button, you can open completely this window. It's possible. So we have a separate communication object available for limited operations, so limited travel range, for example, or you can enable limited traveling also via a communication object additionally. Yeah, a bit special. Or special parameters you see here, dead times. What does it mean? So we are responsible for the shutter actuator, the operation, maybe also for the motor, our installer at least, yeah, but not for the hanging normally behind, for the shutters and blinds, which of course are also part of the total solution. And the shutter, the blinds, the hanging are a mechanical part, with ropes and with any parts inside, which causes also sometimes, let me say, deviations in operation. Yeah. So, for example, if you start the motor's already running, but you don't see any reaction at the blinds outside, with a delay of 1 second maybe, because the mechanic has still some tolerances and is not running immediately after the motor has already started. Yeah. And this causes sometimes problems at a complete facade, for example, if all the hangings have to be positioned at the same level in the evening maybe, and it does not work because there are mechanical tolerances inside this hardware. So on this we can overcome the situation with these parameters. We have 3 different ones. For example, here dead time of blind shutters from button until moving up. So it's down the blind, you start the motor, but it's not running immediately. Maybe after 1 or 2 seconds it starts only to move. On this you can adjust here this dead time in this parameter. Yeah. The same principle here for the lamellas. If they are completely closed and you try to open this, there might be also a slippage and a tolerance, and this time you can adjust here as well. And finally, if you run the motor and change directly the direction of rotation, also a tolerance might appear here, and also via time you can overcome the situation. Yeah? It's not for the daily business here and for every project and for every blind you have to adjust here, but in some special cases you can use this. And if somebody asks you about synchronized running, you can say, okay, it's not directly our part, but our parameters in the shutter actuator can help in this regard. So, what else do we have? Tensioning of the awning or slot positioning. What does it mean? I go directly to an example. If you have an awning for shading of your terrace or your balcony, you can move it out or run it out. What happens normally? It's out, but the textile blind is hanging a bit because it's not tightened. To do this, you have to move back the motor 1-2 seconds, and then it works, or it looks fine. So we have to have a kind of special function. We have to run out, but also go back for 1 or 2 seconds to have a proper situation with your awning, for example. Yeah? So you can do this manually. If the motor has stopped, you go back again for 1-2 seconds, but we can also automate the situation with these special, let me say, parameter. And another application might be a shutter, which consists also of some lamellas, but if it's going down, it's completely closed. And if you go up again a bit, it opens a bit the slots between the lamellas, just to get some light inside the room. Also a function of going down and then going up for 1-2 seconds. We can automate this with this solution as well. You see here the parameters. For example, if you reach the end position, then you say, okay, just 2 seconds or 500 milliseconds, whatever you want, open again, and then you have the right situation you would like to have. Yeah, let's come to the safety functions we need in many solutions. Think about any wind or rain or frost alarm we might need. So wind can be dangerous for the hanging or the shutters and blinds. Rain, for example, could be dangerous for a roof window. So you have to react on this. And important is that this solution runs with a higher priority. Means also the local operation is blocked in such a case. If the wind or rain alarm has sent an alarm to our shutter actuators to move up or to close the window. Priorities between these safety functions, wind, rain, frost alarm, plus block and forced operation, additional functions, can be set inside the device individually. So whatever means highest priority, it's up to you. And for example, you would like to have forced operation as a highest priority. Forced operation maybe will be used for opening the blinds in case of cleaning of the windows. So in this case, nobody is allowed to do anything anymore with the blinds, and so this will be the highest priority, for example. So neither local operation nor any other central commands can then run the motor anymore. Yeah, if you look to this forced operation here as an example, for these special functions, you can send a 1-bit telegram to your channel. It will go to a defined position. You can program here. And then again, for any other function, it's not possible to run the motor anymore because it's blocked. Good. Yeah, let's come to the sensors, the weather sensors. We have, of course, in our range of KNX devices also some components. If you need only a brightness sensor for sun-dependent shutter control or blind control, you can use our HSS 421 with a dedicated sensor. Or you use our weather unit, which consists of a KNX device plus a multi-purpose sensor here, which has brightness sensors integrated, wind sensor, but also rain sensor. A further option, very often used in residential projects. And if you need a special solution regarding sensors, you see here our weather station 4.1, WS/S4.1. It's in principle an analog input with 4 channels and a special software which allows you to connect any conventional weather sensors which have such an analog signal, like 0 to 10 volt or 4 to 20 milliampere. And the software inside this weather station is prepared for different kind of weather sensors. So you have then the right parameters for each of your sensors inside this device, to have a complete weather station connected to KNX finally. Yeah, and what can you do with such sensors? Already mentioned a bit, but you see here again the topic wind, rain, and frost alarms, or weather dependent alarms or situations. And priority can be adjusted, but also, of course, what shall happen in case of any wind, rain, or frost alarm. So you are very flexible, going up and down, stopping the motor, or go to any position, or even more interesting, to go to any individual position. You can adjust here as well. Individual position means always the height of the hanging, but also, if available, the position of the louvres or the lamellas. It's always possible. So you're very flexible to do whatever is necessary in case of any weather alarm. And furthermore, if you would like to position directly your blinds, via one byte telegram, yeah, sometimes also necessary from a visualization, for example. It's either possible we have communication objects both for blind position or lamellar position. If you send there a value, it goes directly to this position. If you don't want to send one byte telegrams, you can also use a preset functionality. Preset you might know from DIM actuators. Preset will be activated via a 1-bit telegram. And in total we have 4 presets available, and you assign in the software to a preset again a dedicated position, which will be activated then via the 1-bit telegram. But it's also possible to change this position, to set a new position. Let's make an example. The customer has a local push button. By pressing shortly, he will activate the position. But if you have run the motor in another position, he can store by long operation, for example, on the same button, the new position. It's possible with, for example, the application shutter, long and short operation in the push button, and then you have a double function on this push button. Good, and finally also into 8-bit scenes, shutter outputs can be integrated. So if you activate a scene, you can also say, okay, go to 50% with the blinds in the same room, and via 8-bit scenes, easily integratable here. You see, I assign it to a scene, and then again, I adjust in the parameters which position shall be behind this scene for each channel if you want. Yeah, and now I would like to hand over to some more applications, sun protection, heating, cooling, automatic, and so on. So Jürgen is just coming over, and I hand over to him my headset, and just wait a moment, Jürgen will continue then.
Hello and welcome to the second half of this webinar, Shutter Control with KNX. My name is Jürgen Schilder and I'm going to continue this webinar. I'd like to explain you the automatic control functionality, the Ibas tool, how to test your settings which you have made in the ATS by using this Ibas tool, and I'd like to introduce you the technology of SMI. So let's switch off the webcam. Good, the software inside our shutter actuator offers more than only driving up and down or drive to position or call a scene. Thorsten introduced you now the main functionalities of the ATS parameter. However, we can do a lot of more things. The shutter actuator allows, for example, the so-called automatic control functionality. We can, for example, realize sun protection as a standard functionality. I'll explain you some slides later. Also, for example, with tracking of the sun position, we can change the angle of the lamellas and the slats. We can use, for example, the natural sun outside in the so-called heating, cooling, automating for energy efficiency solutions. Or we can redirect the sun rises inside our room, for example, via special kind of lamellas. Or additionally, we have a feature, for example, to use a kind of night cooling to get the fresh, cool air inside our building, also for energy efficiency solution. So now let's have a look at the first, maybe the standard solution about sun protection. This is maybe the easiest way. We need outside a brightness sensor which measures that we have brightness, that we have sun or no sun, and then we send this information directly to our shutter actuator. Like here, outside we have no sun, and then we send the information to the shutter actuator, no sun outside, and we have activated, of course, the automatic mode, and then the lamellas or the blinds drive here and the position up. So now during the day outside we have sun, a lot of sun comes from outside, and then we send the information to the actuator, and the lamellas or the shutter blinds drive down to protect here our room that we have no sun inside. So you can work inside your office. We get some maybe diffused light here inside, but we cannot see the sun, and so we can still work here maybe on our table, and we cannot have a view inside directly into the sunrises. So this here is the principle of our sun protection, so-called standard. So, but to realize this functionality, we need additionally outside the brightness sensor, like for example here. This one, he measures the brightness and sends it here to our evaluation device inside the building. We need one rocker here for the direct operation, maybe to drive the shutter and blinds inside the room up and down, and additionally a second rocker, or maybe you can realize it via time switch, to activate or deactivate our automatic control mode. Now when we have deactivated it, then we can via the manual operation drive the shutter up and down, and via another rocker we can activate it, and then the shutter actuator is listening to the brightness sensor and drive here in the position for no sun or in the position for sun. So all other logic we have still here inside our shutter actuator per channel. So we can do all the settings, channel A, independent B, C, and so on. So here in this overview you can see here maybe some how it works. One rocker to drive it direct up and down, and here with another rocker we disable or we activate or deactivate the automatic control. When we press here on the right side, we send the value 1 and we activate now our sun protection. So the shutter actuator is now listening here to the brightness sensor, and if the brightness sensor sends the value number 1, then he drives in the position for sun. The position now is stored here inside the actuator. He receives only the value 1, it is sun, and then he drives in the position for sun, for example down. Or he receives the information no sun, which is the bit value 0, and then he drives into the position no sun, maybe for example in the position up. And all other logic we have complete here inside our actuator. So far this is the overview or the principle about the sun protection standard. Here a screenshot of the ETS parameter. You can see here the position for sun, the value 1, then he drives for example down, or the position for no sun, then he drives up. So this is the principle. Now when we want to do more features, for example, with tracking of the sun position, then we need additional hardware. We need one device, our so-called shutter control unit, GSB/S. This device calculates automatically the position of the sun. So we have to set some parameters inside the device. One, for example, is the location of the building, so the data of the building, the longitude, maybe east-west, the latitude, north-south, and the direction of the facade. And depending on the time and date, this device knows exactly the position of the sun, and then this device sends an 8-bit value directly to our shutter actuator and change the height of the lamellas and the angle of the slats. That's the principle about the tracking of the sun position. So additionally, we need here our shutter control unit, and still like before the brightness sensor, and here our rocker or sensor for the direct operation of a deactivate or activate our sun protection. The complete other logic is here still inside our shutter actuator. This principle with tracking of the sun works only together with our ABB devices, because we need here some information which are calculated by the shutter control unit. We have here these communication objects and of course in our shutter actuator. So really only with these ABB devices we can realize this sun protection with the tracking of the sun position. So here's the principle. We have still the same, our one rocker for the deactivation or activation the automatic mode. Here we have it now activated by sending a value 1. Then the shutter actuator receives the shutter control unit receives the value from the brightness sensor. It is sun or no sun. He knows the time and date, the position of the sun is calculated, and then he sends the information via a 8-bit value, the position, the height of the lamellas, and the angle of the slats directly to our actuator. So he sent really the value. The value is not stored here inside, because depending in the morning, afternoon or the evening, the position of the sun has changed, and every time he sent the values directly here to our actuator. Or when outside there is no sun, the shutter control unit sends the value no sun, and then he drives here in the stored position for no sun, for example, up. So this is the principle with our shutter control unit and our shutter actuator. So additionally, we can see here the telegram, our ETS parameter. For example, the position here for sun, the logical one is the sun outside. And then we have here one parameter, receive, position and sled via object. This is exactly this one here. The shutter control unit calculates the position of the sun, and then he sends the value drive in 50 position and change, for example, the angle of the lamellas about 25%. So he sent this value via this parameter here. So additional functionality is the so-called automatic heating cooling. We can use, for example, during the winter time, like here maybe in Europe, in Germany, the sun outside to heat up our room. So we have in winter the heating period. Inside our office we need additional maybe radiator or electrical heating system. And now when nobody is inside the room and outside we have a lot of sun, then we can drive up here our shutter and we can use the natural maybe energy produced by our sun to heat up here the room. So we can harvest here our energy and use this energy as energy efficiency solutions for heating the room. So we need here two information. The first one, nobody is inside the room, and outside we have enough sun. So during the night, for example, or when we have no sun, then we can close here our shutter and blinds to protect that the heat of the building goes outside maybe here and the building cools down. So this is a so-called heating automatic. And we can do the same vice versa, maybe in other countries, to protect here our device against the sunrises. We need additional the same information. No one is inside the room. Outside we have sun and we are in the cooling period, maybe during the summer. And then we can close, or the system can close automatically here. Our lamellas drive down and close, so it's prevented that the sunrises can go inside the building and heat up the building, because we need energy to cool down, and so we can protect here kind of shading that no sunrises can go inside. So this is the additional function, cooling or heating automatic, we can use in our actuator. So in here the principle again, we have the rocker to activate our automatic control. Then we need a presence detector or maybe a keycard reader or something else, which gives the system the information the room is occupied or not occupied. For example, if the room is occupied, someone is inside the room, he is working on his desk, for example, then we have still the principle like before, our automatic sun position. So the shutter actuator drives in the position maybe for sun or for not sun. But now we want to do more. Nobody is in the room, so the presence detector or the keycard reader said nobody is inside. Then we can additionally enable our heating or cooling automatic. And then depending on the temperature inside the room, then we have the information, we have the heating mode or we are in the cooling mode, and we have sun outside, and then we can drive here automatically in the position. For example, if we are in the heating mode, we have sun or we have no sun, or now when we are here in the cooling mode, also the same, the position for sun or for no sun. So this will be the, I think, a good possibility to save energy. No one is in the room, we have sun outside and we are in the heating mode, drive the shutter up to harvest the natural energy which comes from the sun. Or the other way, no one is inside the room, to close, to drive down our shutter and blinds to prevent that the sunrises heats up here our room. Okay, so far this is the heating cooling automatic, and here again we have the parameter. Here for the heating mode, for example, what should happen when the heating mode is active, we have sun, or for the cooling mode, so we can see here a small screenshot including the parameters. So we have maybe another functionality, the so-called overheat control. When we have activated our automatic heating, so we are like before, we are here exactly in the situation. We are in the heating mode, we have a lot of sun, no one is inside the room, the shutter drives the position up, and we use the natural sunrises to heat up the room. But now when we have more than a special maybe fixed value here, 24 degrees, we can drive in another position. When we have 21 degrees, 22, 23, everything is fine. The natural sun comes inside and heat up the room. But then we reach here a limit, maybe 24 degrees, and then the shutter or the blinds should close automatically and drive down to prevent that the room becomes 25, 26 or 30 degrees. For this case we have here our so-called overheat control. When we have enabled it, we can here use our threshold, and then we can set here parameter what should happen when we reach our threshold, for example, to drive the shutter down. This is the so-called overheat control. So the next automatic control is the redirection of the daylight. The first step is we need here some special kind of slats or lamellas. You can see here on the right side a type of these special devices. The surface of the devices is like a mirror. So these are not standard slats or lamellas. They have here the surface like a mirror. And though the sun rises, which comes from outside, can be redirected here inside the room. So we get enough natural light from outside, but you can still sit here on a PC. You can see no sunrises, but we get a lot of natural light inside, maybe to save the electrical light, so we can switch here off automatically our light inside the room. In this case we need again our shutter control unit, which knows the position of the sun, and we need here this kind of special slats. So or here the principle of the so-called night cool mode. Maybe during the night or in the morning, maybe for example in a fabrication hall before the worker starts with their job, it is possible to open here the skylights or the windows to get cool air from outside the building. And in this case it makes sense to have or to fulfill two conditions. One is that we measure inside the building or inside the room the temperature, and it makes only sense to open the window when the inside temperature, of course, is higher than the external temperature. The external temperature must be also measured, and then when the outside temperature, for example, is lower than a defined value, the windows, the skylight opens automatically, and the hot air goes outside, and inside there comes the cool air from the region. It's also a possibility we can use here in the automatic control. So now some words about this SMI technology. Some of you knows this system. This is quite common in some countries here in Europe, for example in France. Behind this SMI technology, it is not new, it is some years existing, and now we have some actuators for the system, and I'd like to explain you something about this technology. So this SMI is a kind of digital interface to control electrical blinds, shutters, or also windows. So for opening or closing the windows. And all the telegrams between our actuator, our SMI actuator, and the motor are exchanged via the SMI protocol. So this means we need also special kind of motors. So we don't use a standard motor with 230 volt. We need so-called intelligent motors, SMI motors. And then our actuator sends the travel telegram, drive to position, up, down, or value to the drive, to our motor. And now the drive is very intelligent, and he can send back the status messages to our actuator, and then we have the information in our KNX world. So in this SMI certified products works together because there are also a lot of manufacturers which have this compatible SMI motors. You can compare this SMI technology like DALI. DALI is to control, is also a digital interface to control the electronic ballast or transformers via also a standardized protocol. And here in the SMI world we have nearly the same, but for controlling shutter, blinds and windows, for example. To control via SMI devices we have a lot of more advantages. One, for example, is we can have a very precisely position of our slats, the height and also the angle of the slats. Additionally, we can read out the position very exactly, and we get the status messages back from our actuator if we have a motor fault or the motor drives up or down and so on. And behind this SMI standard there are some manufacturers, European manufacturers. They have specified here this protocol. Some words about the technology. On one SMI cable we can have up to 16 devices can be here controlled. Yeah, so 16 is the maximum number, and on the market there are SMI motors or drives for the mains voltage 230 volt and for 12 or 24 volt DC, the so-called low voltage LOVO motors. And for both of these motor types we have actuators, later you will see. So here are some of the members of these SMI groups, manufacturers of motors and drives, for example, Elero, Selve, Baker, and partners. Partners are, for example, companies which produce gateways between intelligent systems like KNX, like ABB, who will do it. We have a gateway between KNX and this SMI technology. So for more details you can visit the website of this SMI group, smi-group.com. The website is available in the German language and English, so you can change here by pressing this button to English. You can see the available products about energy efficiency, what is SMI, and you can download also some brochures, planning brochures about SMI technology and so on. So here's some words about the technology. SMI is like DALI, a master-slave system. So here we have our control unit, for example our shutter actuator. Then he is the master, he sends the command, digital signals up to 16 slaves, which can be connected to one SMI cable. So it means each of the motor has an address, an individual address, like from 1 to 16, and we can create here groups, or we can send also broadcast telegrams. So the SMI cable is, for example, a 5-core cable, so we need here the protection earth, the neutral, and the phase, the energy to the motor, and the 2 other cores we can use here in the same cable to control our SMI motors. We have here the minus and the plus. So the advantage, the motor can send back via these 2 cores exactly the positioning of the motor, or the motor has a defect, and via our KNX world we can send via the gateway exactly positioning up to 2 degrees per step, so very exactly positioning. So the topology of how to install the cable is absolutely free, so we can make a star, a tree. So the only limitation is here the length of such a SMI cable is allowed up to 350 meters, and the data transfer we have here about 240 bits per second. So, and it is allowed to use one cable here for the energy, supply the energy of the motor, and use 2 cores here for SMI. The polarity is important, so we have here minus and here plus. So here's the overview how we can use our SMI actuator. We have still here our KNX world with all the sensors for the manual operation, or we can use here our automatic control with the sun protection, the tracking of the sun via the shutter control unit. The same like our standard motors, but then we have here our SMI actuator. This one, JAS4 SMI1M, this is one actuator with 4 outputs. So here we can control 4 outputs, and each output it is possible to connect up to 4 motors. And all motors in one output or which one group drives every time in the same position or in the same height. And these motors can send back the status via SMI protocol to the actuator into our KNX world, and then we have maybe the status or fault messages. This is the shutter actuator SMI to control 230 volt motors, which are quite common used outside the building, like here the lamellas, the slats outside, or the hanging, and here for the pool. Inside the building, that's quite often used the low voltage motors, the 24 volt DC, like here for example the roof windows or the skylights. For this case we have here our actuator for 24, which shows you 24 voltage low voltage. So then we need here this hardware. The principle is the same. We have 4 outputs or 4 groups, and each group we can connect up to 4 SME drives for opening the window, or like here for example the roof window. The advantage, we can send back the communication commands into to our SMI motors, and we get back here the feedback. So this is the shutter actuator to control the 230 volt motors. Here we need KNX, we need a 230 volt operating voltage, and here we have the 4 outputs of our 4 independent groups, and only the limitation 4 motors here per group. The same in our low voltage actuator. The only difference is here that is allowed to connect 24 volt SMI low voltage motors. The application or the software parameters I show you later. At first here, before now again a slide about the wiring diagram. Here we have our actuator, then we have the 4 groups, the 4 outputs, and per output it is possible to connect parallel up to 4 SMI motors. Here maybe to our output A or here to our output D. And the same here in our low voltage actuator. Our motors will be supplied via 24 volt DC, and via SMI they get here the information, position, height, and can send back status. The software application of these SMI actuators is the same like in our standard 230 volt motors. So we can drive it up and down, position, scenes, the sun automatic, the tracking of the sun, the heating, cooling, the wind alarm, the blocked forced operation, and so on. So this software or the functionality is the same like our standard actuators. Plus here the advantage of our SMI actuator, the position exactly about 2 degrees per step and so on, the position of the Louvre. For example, we get information how many devices are connected to our SMI, diagnostic byte, and so on. Some more information we get here via the SMI technology. Good, so far some words about SMI. I would like to introduce you now the Ibas tool, what we can do together with the shutter actuator and the Ibas tool. Some examples how we can test all our settings. You have seen we have so many parameters inside our shutter actuator. The heating, cooling, automatic, the scenes, the priorities, the scenes, a lot of things. And after you have set all these parameters, it is necessary to test the shutter actuator. If the priority is the correct way, so you say, okay, the weather alarm has the highest priority, and then the forced operation and so on. You can do it by sending group addresses via the group monitor, the ETS, or use the Ibas tool. The Ibas tool is a software which works only together with our ABB devices, so it's really advantage to use here our KNX devices. So I share my desktop and show you the Ibas tool. So just give me a second. So I start this Ibas tool. The Ibas tool is a software made by ABB. It helps you during commissioning. It's free of charge. You can download it from our website. It's available in several languages. The first step is to start the ETS, to do all the settings you want in your ETS application. The parameters, what should happen in, we have rain alarm, frost alarm, forced operation, all the settings. Download these settings to the actuator and then start the Ibas tool and test your settings. So I use here, for example, the button connect. I connect to my shutter actuator. That's why I need the individual address of my actuator. Here my demo board, my actuator has the address 1185. It is possible to connect via USB or also IP, via VPN tunnel from outside the building, maybe to a customer. When he has problems, we can use also this Ibas tool for diagnostic. It is not possible to change a parameter or to delete or add a group address. This is what we are doing with our ETS. Here this is only a kind of diagnostic software or to test all your settings. So now we can see here on an easy kind of visualization all our settings. Like here, for example, my channel A, I have disabled the automatic control. That's why here this is gray. So in my channel A, I have only activated the standards features. Maybe I have activated the weather features, but no automatic control. So here, for example, my channel number B, I have enabled the automatic control. That's why you see here the automatic control, the heating and cooling mode is also enabled, and now I can send here information by pressing or by activating the so-called configuration mode. So I click here Yeah, and then I can send telegrams here via this Ibas tool to my actuator and test different things. For example, I can click here on this button, yeah, and then my motor or my shutter drives in the position down. I can see here my travel time, for example here 6 seconds, and after 6 seconds he reached the upper position. You see here 100%, and here the angle of our slats or of our lamellas. So, and now I can here, for example, call a scene. Yeah, I have here specified some scenes, scene number 1, scene number 8. When I press here, I can call a scene or I can store a scene. I can use the preset functions, yeah, which I can call different positions. Yeah, I see here also some status messages of my actuator, and I can also simulate a wind alarm, yeah, or a rain alarm. For example, here on the bottom, yeah, maybe outside I have not installed a weather station, but now I can test the behavior. Yeah, I set here parameter. In case of rain alarm, I want to drive down my shutter. So I simulate here, I activate a rain alarm. Yeah, the first step is, you see here, this is the feedback. Yes, weather safety alarm is active. The motor is now in motion. Yeah, and here the status rain alarm is active and the motor is in the position down. Yes, this is correct. I want this feature. But when I want to have wind alarm, it should drive in a position up. Okay, let's simulate a wind alarm. Click here on the button wind alarm on the bottom. Yeah, and then he should drive in the position up. Yeah, the motor now is in motion. Yeah, and after the travel time is over, you will see the motor is in the position up here 0% and the slats are completely open. And so I can test it. What should happen in case of rain alarm, down, wind alarm up, and the highest priority. It's a parameter what has the higher priority, the rain or the wind. And now I selected the wind alarm, and so when I have both, I can see yes, it is okay. Now when we detect here a mistake, we made some mistakes in the parameterization, the ETS, close the Ibas tool, go back to the ETS, change the settings, download the settings to the device, start the Ibas tool again, and test if everything is okay, depending on the requirements of the customer. So now then we can deactivate our wind alarm, our rain alarm, and everything so far is okay. So next step is we can also test our automatic control. The automatic control we can activate via one bit telegram. I can simulate it here, maybe via one rocker or via a time switch. So let's activate here the wind alarm. The automatic control. Now the automatic control is now active. Here we can simulate also the sun, yes or no. And I have here set a parameter when we have sun outside. He should drive in the position 50%. And change the angle of our slats 40%. You can see here, now he's in the position 50% and 40% the angle. And now I can simulate here my shutter control unit. I can say, okay, now when we have more sun, for example, go in the position 40%, and here maybe the angle should be only 19%. So I write this value, and you will see after some seconds he drives exactly here in the new position. So this is what normally is calculated automatically by our shutter control unit, and I can simulate it here. Or when we have no more sun outside, what happens? He drives in the position of no sun. Wait some seconds, then you will see the motor, the blinds drive in the position up because we have no more sun outside. So you can test all the settings here for the automatic control. Let's activate again. Automatic control. We have sun outside, and here presence. Presence means the room is occupied. We are in our office. But now when we are leaving our office, the presence detector said no, room is not occupied, and we are in the heating mode. What happens? We can use the sun which is outside to heat up the room. You will see the shutter and the blinds drive in a position up, and we get a natural sun from outside. We have sun, and the room is not occupied. So you can test exactly this principle here. Or now we go here, for example, the room is activated, the room is occupied, we come inside in our room, then he stops our heating automatic and he's doing only our standard automatic control and drives in the position for sun and so on. With this Ibas tool, really, it's a nice thing to test all your setting or to do diagnostic. The customer gives you a call, I cannot drive, for example, down my shutter, where's the problem? Then you can start here the Ibas tool and you can see, oh, maybe there's a forced operation active or a blocking function, that's why you cannot drive down the shutter. So, and my channel D I have parameterized as a switch mode. So maybe I control here some ventilation flaps, yeah, or some dampers. Yeah, and also here I can simulate opening or closing, for example, here my relay on my channel number D and test here my ventilation flap or my damper. I can simulate here also maybe wind alarm in case of wind alarm or rain alarm or frost alarm. The flaps should be closed, and then I can simulate here and test everything is it's correct. Good, so far a small impression about this Ibas tool to test all the settings of the ETS parameters, wind alarm, forced operation, or for doing diagnostic. Good, so far now I go back to my presentation. Stop sharing. Okay, so far the Ibas tool. More details about shutter control you will find on our website, so abb.com/knx. Here in our so-called product tree, and here we have the submenu shutter and sun protection. Here we have an overview about all our shutter actuators, the 230 volt, the SMI, the shutter control unit, which calculates the position of the sun and so on. So for more details, please go here on our website. Documentation, of course, we have the product manual, the description of all ETS parameters, description of the communication objects, and so on. For maybe more application oriented, we have here our so-called application manual shutter control. Here we have also a description how it works together between the shutter control unit, our shutter actuator, and so on. So this is also available as a printed version. As a PDF, we have the product information, we have technical data sheets, and some things you will find everything on our website. So additionally, we have some e-learning modules, which are kind of animated PowerPoint presentation available in German and English language, also on our website abb.com/knx. It's also introduction about the shutter control with KNX. So we have not to sign in, you can go on the website and start this e-learning module. It's about 10 to 15 minutes. Good, so far. Now we are at the end of our webinar. We are looking forward to see you again in September. Enjoy your summer holiday, and thanks for taking part this today, and see you in September. Goodbye.